In the heart of Victoria, Australia, nestled in the rugged terrain of the Malagal goldfields, two Cornish miners, John Deason and Richard Oates, made a discovery that would etch their names into the annals of history. On the 5th of February 1869, while working the fields of Bulldog Gully, they uncovered the largest gold nugget to have ever been discovered. It was of unprecedented size and weight, and was later named the Welcome Stranger. The nugget was buried just a few centimetres beneath the surface, near the roots of a tree. Upon unearthing it, Deason and Oates quickly realised they had found something extraordinary. The sheer size of the nugget was such that Deason reportedly broke 2 pick handles trying to dislodge it from the earth. The nugget measured roughly 61 centimetres by 31 centimetres, or 24 by 12 inches, and had an irregular shape, resembling a mass of gold fused with quartz. Its appearance was so astonishing that upon discovery, Deason and Oates decided to keep the find secret until they could safely transport it. Under the cover of darkness, they transported the nugget to Deason's hut, where they kept it concealed until the time was right to move it to the nearby town of Denali. Though secrecy is to be expected when one discovers such a monumental gold nugget, there may be more nefarious reasons for their secrecy, which I'll explain later in this video. Malagal is part of the broader region known as the Golden Triangle, famous for its rich alluvial and hard rock gold deposits. The geological makeup of Malagal includes extensive alluvial plains, formed by ancient river systems. These plains are underlain by deeply weathered bedrock, and are characterised by quartz veins or reefs that have been the primary source of gold in the area. Over millions of years, these quartz veins weathered and eroded, releasing gold into the surrounding soil and riverbeds. The gold found in Malagal, including the Welcome Stranger, is largely alluvial, meaning it was deposited by water movement. The area's gold deposits have been concentrated in the riverbeds and creeks, where the heavy gold particles settled and accumulated. This process, coupled with natural weathering, led to the formation of large gold nuggets, which could survive the forces that pulverised lighter materials. The region's nickname, the Potato Diggings, reflects the size and frequency of these gold nuggets, with many resembling the size and shape of potatoes. The quartz in the Welcome Stranger nugget was black. This black quartz likely resulted from the presence of impurities, such as manganese oxides or other minerals, which gave the quartz a darker appearance. When Deason and Oates found the nugget, they initially mistook it for a large stone because of the dark colour of the quartz. Only after closer inspection did they realise it was a massive gold nugget encased in quartz. Black quartz, or quartz with a dark coating, is not uncommon in gold-bearing areas. The coloration can occur due to various mineral inclusions or surface staining, which often results from chemical interactions between the quartz and other elements in the surrounding environment. In the case of the Welcome Stranger, the black quartz was part of what made the nugget so unique and notable, as it highlighted the unusual combination of pure gold and dark quartz, making it stand out from typical gold nuggets that are often associated with lighter coloured quartz. The geological history of Malagal and the surrounding Bendigo zone, part of the Western Lachlan origin, is intimately tied to subduction processes. During the Paleozoic era, particularly from the Ordovician to Devonian periods, around 485 to 359 million years ago, the eastern margin of the Gondwana continent, which included what is now Victoria, experienced subduction of oceanic plates. This subduction led to the creation of extensive sedimentary basins, where fine-grained sediments were deposited. Tectonic compression during the Lachlan orogeny resulted in the folding and faulting of these sedimentary layers, creating the complex structures that host quartz reefs. Hydrothermal fluids associated with subduction-related magmatism infiltrated these folded and faulted rocks, precipitating gold within the quartz veins. This unique geological setting led to the rich endowment of gold that was later concentrated in alluvial deposits by erosion and weathering. Malagal and the surrounding region have piqued my interest for years. It's my belief that something different took place here which produced such large gold nuggets. This is an area of study that I'm still engaged in, but I believe there was an additional and crucial volcanic component that led to the vast enrichment of the area. The Welcome Stranger nugget was not only the largest gold nugget ever discovered, but also one of the heaviest. After removing impurities, such as quartz, the nugget yielded around 2,284 troy ounces, which is 71 kilograms or 156 pounds of pure gold. The value of the nugget was substantial, even at the time. The nugget was sold for about £9,381, which would be worth millions in today's money. To calculate its current value, we can use the current gold price. As of now, gold is priced around 3,721 Australian dollars per troy ounce. With the nugget containing approximately 2,284 troy ounces of pure gold, its value today would be around 8.5 million Australian dollars. Handling a nugget of this size and weight presented significant challenges. They transported the nugget to the blacksmith shop of Archibald Walls in Denali. There, using an anvil and hammer, they broke the nugget into 3 pieces, because the nugget was far too large and heavy to use scales to weigh it. There are reports that to facilitate this process, the nugget was heated overnight in a fireplace to make the quartz more brittle, a technique that would have made it easier to break apart. By heating the quartz, Deason and Oates made it more brittle and easier to fracture, which allowed them to separate the gold from the quartz more effectively. Once broken down, the gold could be transported more easily and weighed using the scales available at the time. But the story of the Welcome Stranger is not without its controversies. Rumours suggest that Deason and Oates may not have been working on a legitimate claim at the time of their discovery. It's even suggested that they claim jumped onto another mine's territory and worked the ground there. There were concerns that they might have been operating without a proper miner's right for the claim containing the nugget. This speculation is rooted in the practices at the time, where claim jumping was not uncommon. Given the value of the nugget, it was a plausible fear that the government or the mine in question might step in and claim ownership. There were historical precedents for this, as seen in other nugget discoveries where legal disputes significantly reduced the prospector's share. To avoid such issues, Deason and Oates acted swiftly to move and sell the nugget. The sequence of events from the discovery of the nugget to its eventual sale unfolded rapidly, driven by the need for secrecy and security. On February 5, 1869, Deason and Oates discover the Welcome Stranger Nugget, supposedly in Bulldog Gully. They transported it to Deason's hut under the cover of darkness. In the following days, the nugget was kept hidden, and plans were made to transport it safely to Denali. Deason and Oates likely realised the risks involved, including theft or claims from others, which led them to act cautiously. The nugget was moved to Denali, hidden in a farm cart under bags of produce. The partners take it to the blacksmith shop of Archibald Walls, where it is broken down into 3 pieces. The discovery of the Welcome Stranger Nugget quickly became a spectacle, drawing crowds of curious onlookers and fellow miners eager to catch a glimpse of the enormous gold find. The nugget's discovery in February of 1869 created a buzz not only in the small town of Denali, where it was taken for sale, but also throughout the broader Victorian goldfields. News of the nugget spread rapidly, and people flocked to see the largest gold nugget ever found. The excitement was palpable, and the nugget became a local sensation, symbolising the rich promise of the Australian gold rush. The pieces of the nugget were then taken to the London Chartered Bank of Australia in Denali. Initial negotiations with the bank manager led to an agreement, and the nugget is weighed and sold. As mentioned before, the final sale price was approximately £9,381, a substantial sum at the time, equivalent to a considerable fortune. After the sale, the gold from the nugget was melted down and sent to Melbourne, from where it was shipped to the Bank of England. This marked the end of the physical journey of the nugget, but the beginning of its legacy. Despite its fame, the Welcome Stranger Nugget was melted down relatively quick, which meant it could not be properly studied or described in detail. This haste was particularly driven by the practicalities of handling such a large piece of gold, and a desire to quickly capitalise on its value. As a result, there were no scientific analysis conducted on the nugget before it was melted down into gold ingots. However, one person managed to create a lasting record of the nugget before it was lost to history. A sketch was made by a local artist, who captured the shape and appearance of the Welcome Stranger as it appeared when it was first discovered. This drawing is one of the few visual representations we have of the nugget, providing a glimpse into what must have been an awe-inspiring sight. The sketch, though simple, serves as a valuable historical record, offering insight into the nugget's size and shape, and preserving the memory of one of the most remarkable gold finds in all of history. The potato diggings is a colloquial name given to the gold-rich area in the Malagal region during the height of the gold rush. This nickname arose because of the frequent discovery of large gold nuggets, many of which were comparable in size to potatoes. These nuggets were found in shallow alluvial deposits, making them relatively easy to dig up, much like harvesting potatoes. The fertile goldfields of the potato diggings attracted countless prospectors seeking their fortunes. with many striking it rich in the process. The discovery of the Welcome Stranger was one of the most famous examples of these finds, proving the area's reputation for yielding large and valuable gold nuggets. The Welcome Stranger Nugget remains a symbol of the Australian gold rush era, epitomising the allure and mystery of gold mining. The discovery not only brought wealth to Deason and Oates, but also highlighted the potential of the Victorian goldfields, attracting more miners and contributing to the region's economic development. An obelisk now stands near the site of the discovery, assuming they discovered it there at all, commemorating this remarkable find. While the original nugget was melted down, replicas can be seen in museums, preserving the story for future generations. The Welcome Stranger Nugget is a reminder of the rich history of gold mining in Australia and the incredible geological processes that can concentrate such vast wealth in the earth. So the discovery of the Welcome Stranger Nugget is a story of fortune, geology, and the adventurous spirit of the gold rush. The immense size and value of the nugget reflect the unique geological conditions of the Malagal region, where nature's forces over millions of years deposited gold in a way that has fascinated and enriched humans. From the moment of its discovery to its sale, the nugget's journey illustrates the excitement and peril of gold mining in the 19th century. The legacy of the Welcome Stranger continues to capture the imagination, symbolising the dream of striking it rich that drove so many to the Victorian goldfields. The geological processes that shape the Bendigo region, involving ancient subduction, sedimentation, and the formation of gold-rich quartz veins, have left an indelible mark on the history and landscape of Australia. As a part of the potato diggings, the area remains a poignant reminder of a bygone era when large gold nuggets could be found just beneath the surface, waiting to change the lives of those fortunate enough to discover them. I hope you found this to be as interesting as I did, and as always, thanks for watching. It's time to discuss deep leads. Across Victoria, many hidden rivers of gold still lie in wait. They've never been found. It's only recently that technology has enabled us to get a clear picture of these hidden rivers buried by volcanic lava. And in this video, I'm going to show you a deep lead in Meredith. This will be part 1 of a series I have planned where we will look at undiscovered deep leads. Some are clear-cut, others less so, depending on the amount of volcanic eruptions that occurred. Be sure to subscribe and click the bell icon to be notified of future episodes. In this video, the buried river is one of the more obvious ones. But what are deep leads and why are they so significant? Deep leads are often rich in alluvial gold, making them highly valuable to miners. The gold was originally washed down from surrounding highlands and deposited in the bends and beds of these ancient rivers. When these riverbeds were buried by natural processes, the gold was preserved along with the gravels. Since surface gold is more easily depleted, deep leads present untapped sources of gold, often holding significant quantities that were inaccessible to earlier miners who lacked the technology to locate or excavate these deeply buried deposits. During the gold rushes of the 19th century, especially in places like Victoria, deep leads became some of the most sought after targets once surface gold had been depleted. Early prospectors focused on easily accessible gold in streams and rivers, but as these sources were exhausted, miners turned to deep lead mining. These hidden rivers were often more difficult and dangerous to mine, but they were also incredibly lucrative. Some of the richest gold finds in Victoria's history came from deep leads. These ancient river systems were part of the larger river networks that stretched across southeastern Australia, and were in existence since at least the late Cretaceous period, around 65 to 100 million years ago and possibly earlier. They carried alluvial gold and other sediments as they meandered through the landscape until volcanic eruptions, beginning 6 million years ago, completely altered the landscape of Victoria's goldfield region. These voluminous basaltic lava flows buried ancient rivers, leading to the development of smaller creeks which took the place of once mighty flowing rivers. Meredith, nestled between Ballarat and Geelong, has long been an overlooked spot in the story of Victoria's gold rush history. It was the Ordovician gold reefs to the east, in Steiglitz, that captured the attention of prospectors in the 1850s. The steep ridges and quartz-laden hills of Steiglitz were a magnet for hopeful miners, but beneath the feet of those passing through Meredith lay something far more hidden, a river of gold, deep and buried under the volcanic rock that dominates this quiet part of Victoria. Now, to be fair, Meredith has had gold discoveries, An article from the early 1860s mentions that coarse gold was found at a depth of 8 to 14 feet or 2.4 to 4.2 meters, after which the shaft became flooded with depth. Before it did, 2.5 ounces of gold were taken from the hole in a period of 4 days. But this early discovery looks to have been the only time that this location was prospected for the valuable shiny metal. And as the goldfields were plentiful during this time, miners looked elsewhere and Meredith became forgotten. In 1906, renewed interest took place in Meredith, but it appears to have gone nowhere. This deep lead, now visible on magnetic surveys, reveals the outline of a long-lost river system, one that predates the volcanic eruptions that later obscured it from view. The volcanic activity that swept across the region, particularly in the late Tertiary period, buried this ancient river in layers of basalt, the formidable rock that miners once referred to as bluestone. The gold within these rivers became entombed beneath a seemingly impenetrable barrier, one that would remain untouched by the pickaxes and shovels of early miners. If you're enjoying this video, please do me a solid and click the like button to help YouTube recommend it to others. However, the story of these hidden rivers doesn't end with volcanic entombment. The flows of lava redirected surface water, creating new, much smaller streams and creeks. These streams, meandering along the volcanic ridges, became the waterways that locals know today. But the true gold-bearing river remained buried, preserved beneath tons of volcanic material. For years, this deep lead beneath Meredith remained out of sight, and for all intents and purposes, out of mind. Miners, focused on the surface gold in nearby Steiglitz, never thought to look deeper beneath the basalt. But with the advent of modern geophysical techniques like magnetic surveys, the signature of this buried river began to emerge. The surveys clearly indicate the old river's path, snaking its way beneath the volcanic plains like a forgotten treasure map etched in stone. This ancient river was quite long, as you can see, and within it we can see the outlines of some of the volcanoes that erupted lava into the river. Now it's important to remember that lava can flow anywhere that gravity takes it. Just because a lava flow occurred doesn't necessarily mean it buried a river. What we need to look for is the meandering shape of waterways, which this river in Meredith clearly had. This deep lead is just below the township of Meredith today. Yet despite the tantalising prospect of untold wealth lying beneath Meredith, deep lead mining is no small task. These rivers, often more than 30 metres below the surface, require intensive labour to reach. Dynamite becomes a necessity, not a choice, as miners must break through the layers of bluestone. The volcanic rock, hardened over millions of years, doesn't yield easily. It's notoriously difficult to break through. Another thing worth mentioning is that these rivers, whilst buried, still do actually flow beneath the ground. So once they are reached, strong pumps are needed to drain the never-ending water that accumulates within drives as miners chase the course of the river. Mining deep leads is dangerous work. The sheer depth of these buried rivers means that the tunnels and shafts dug to access them are often unstable, prone to collapse under the weight of the earth and rock above. In the 19th century, miners would descend into these treacherous environments, their lives hanging by a thread as they worked to clear the rock and dirt that stood beneath them and the gold-laden gravels below. It wasn't uncommon for tunnels to flood unexpectedly, with ancient watercourses still running beneath the ground, threatening to drown any miner caught off guard. And of course, there was the constant risk of cave-ins, a fate that claimed the lives of many early gold seekers. The river beneath Meredith is no exception. It still flows, albeit quietly and unseen, beneath layers of ancient lava. This buried river once coursed through the landscape, carrying with it gold from upstream deposits, depositing its treasures in the bends and eddies as it meandered across the prehistoric plains to the south. Now the very same river presents an incredible opportunity for modern miners, but only for those brave enough to face the challenges that deep lead mining entails. But of course, this isn't the 1800s anymore. You can't just rock up to a store, buy dynamite and start blasting a hole like you used to. Which is why I'm making these videos, otherwise I'd be out there chasing them myself. Government regulations in Victoria are extremely stringent now too. The days of small-scale gold mining in the country are almost completely over, minus a few exceptions that number very few. Big mining companies aren't interested in chasing these rivers for a myriad of reasons. Mining deep leads is extremely costly. Modern mining companies now have access to advanced technologies, such as open pit mining, heap leaching and improved processing techniques, that allow them to efficiently extract gold from low-grade surface deposits. This is often less risky and less expensive than the hazardous work of mining deep leads. For example, large-scale open-pit mines can process huge quantities of ore with lower gold grades, making it economically viable to target large, low-grade deposits instead of smaller, high-grade deep leads. Deep lead mining is inherently risky. Tunnels can collapse and there's the constant threat of flooding from ancient watercourses still flowing underground. The unstable nature of deep leads means that additional reinforcement and safety measures are needed, which further increases costs. Mining companies often find it more attractive to focus on projects where the risks are lower. On top of this, mining deep leads can have a significant environmental impact. Modern environmental regulations, which didn't exist during the original gold rush, place stringent requirements on mining companies regarding land rehabilitation, water use and pollution control. Accessing deep leads may require disturbing large areas of land. Modern mining companies tend to favour large, scalable operations. Deep lead mining is often labour intensive and requires significant investment for relatively small yields in comparison to modern open pit or underground mines. As a result, it is less attractive to large corporations, which prefer projects that can produce a high volume of ore with fewer logistical challenges. So these videos in this series are more so designed to pique the curiosity and imagination of people such as myself, who have a passion for these types of hidden watercourses. And whilst revealing them brings them to light, the chances of them ever being mined are slim to none. Beneath the agriculturally rich landscape of Meredith, which uses the volcanic soil to create productive crop fields, there are signs of the real landscape that dominated the area for most of Victoria's history. For over 400 million years, Ordovician age sediments interspersed with gold-rich quartz veins outcropped on the surface here. Today we can see a few hints of these outcrops around Meredith, but the majority of it is now a zone dominated by recent volcanism. As we've seen in other parts of Victoria, particularly in Ballarat and Creswick, deep leads have had the potential to yield extraordinary amounts of gold. These buried riverbeds were often the final resting places for vast quantities of alluvial gold, washed down from the surrounding hills and trapped in the gravels of the ancient waterways. The deep lead beneath Meredith, untouched by human hands, could well be one of the richest gold-bearing leads in the region, a treasure trove hidden in plain sight. The volcanic eruptions that buried this river weren't just an act of nature, they were a curtain drawn over the wealth that lay beneath. The immense amount of lava released by these volcanic eruptions transformed the landscape, leaving behind the basalt plains we see today, and covering the gold-rich gravels in a layer of bluestone so thick that even with today's technology, mining them is a monumental task. The streams that flowed after the volcanic eruptions were mere shadows of the original river. These smaller, shallower waterways carved out new paths, flowing to either side of the volcanic rock. They didn't carry the same gold-bearing gravels, and prospectors, unaware of the wealth buried beneath the basalt, overlooked Meredith in their rush to more accessible fields. Little did they know that just below the surface, the ancient river still existed, locked away by the volcanic rock that sealed its fate and its fortune. But let's talk figures for a second. The Creswick area, north of Ballarat, is perhaps the richest side of deep lead gold mining. These ancient waterways were found and extensive work was done to extract the gold-laden gravels beneath the volcanic landscape. Some of the Creswick leads produced up to 1,500 ounces of gold per tonne of gravel. This means that at the current gold price, $5.75 million would be won per tonne of gravel, which is ludicrous to think about. While Ballarat's deep leads produced an immense amount of gold overall, due to the larger area and longer period of operation, the Creswick deep leads were likely richer in terms of gold concentration. But technology, as it often does, has given us a second chance. The magnetic surveys now available to geologists and prospectors alike allow us to peer beneath the surface in ways that would have been unimaginable 150 years ago. The clear outline of the buried river beneath Meredith is a stark reminder that there is still much to discover. The challenge now is to access it. Dynamite, as mentioned before, is crucial for breaking through the hard volcanic rock that conceals the lead. But even with modern blasting techniques, accessing deep leads is a slow and laborious process. The shafts must be reinforced to prevent collapses, and miners must work carefully to avoid disturbing the natural watercourses that could flood the tunnels. It's a high-risk, high-reward endeavour, one that has claimed many lives in the past in horrifying ways. However, the promise of gold is a powerful motivator. Deep leads like the one beneath Meredith have yielded extraordinary returns for those willing to put in the work. The rivers themselves, though buried, still hold the promise of fortune for those who can unlock their secrets. The gold trapped in the gravels of this ancient waterway is just as valuable today as it was when it first settled there, waiting for someone with the right tools and the right resolve to come along and claim it. So this is one of many of the deep leads that were never found during the gold rush days of Victoria. In future episodes, I'm going to continue to expose the many others that I've uncovered. I hope you found this video to be as fascinating as I did. And as always, thanks for watching. The discovery of over 1 ton of gold at Blacksmith's Hole, located in Ballarat's Canadian Gully, marks one of the most remarkable events in Australian gold rush history. Worth approximately 122.83 million Australian dollars at the current gold price, it's considered one of the richest alluvial shafts ever dug, not just in Australia but possibly globally. The concentration of gold in this particular shaft, coupled with the fact that miners reportedly extracted an ounce of gold per bucket of earth, places it among the most productive alluvial gold mining operations ever recorded. This video speaks about one of the earliest discoveries of ancient buried rivers in Victoria, known as deep leads or paleo rivers, which forever changed the course of gold mining in the state and the country, enriching it beyond measure. It tells the story of a man known as Canadian Swift, which is an awesome name by the way, a miner from California's gold rush, and his early contributions. We'll look at the hydrodynamics behind the gold concentration and the broader impact that this discovery had on Victoria and Australia's transformation into one of the richest places on Earth at the time. Canadian Swift, one of the first miners to uncover surface gold in Canadian Gully in 1851, played a significant role in putting this area on the map. Known for his perseverance, Swift dug deeper into the hillsides when others focused on surface alluvial gold in streams and creeks, leading to further exploration of what would become one of the most famous goldfields in Ballarat. One section of Canadian Gully was situated on the White Horse Ranges hillside in Ballarat East, where it extended down into the valley below. Sovereign Hill, a well-known outdoor museum today, is located on the actual site of the famous Canadian Lead, which ran directly through what is now Sovereign Hill. This is significant because Canadian Swift and the early miners in the area dug into the hillside, only to find rich alluvial gold deposits. This was an unusual approach at the time, and it was even mocked, since most miners were focusing on flatter areas and streams for easier to access gold. However, the hillside location of Canadian Gully proved to be incredibly rich, leading to the discovery of the Canadian Deep Lead beneath layers of sediment. For reference, he was digging a shaft 25 meters higher than the surrounding land, but his early successes inspired others to sink shafts on higher ground. If you're enjoying this video, please do me a solid and click the like button to help YouTube recommend it to other viewers. Canadian Swift, though mocked, was an experienced miner from his days in California, and he knew that hillsides contained placer deposits, but he wasn't expecting to find a hidden river buried beneath the sediments on a hillside of all locations. While specific figures on its exact width can differ slightly across various sections, leads in the Ballarat region, including the Canadian Lead, were typically 50 to 100 feet wide, or around 15 to 30 meters. Keep this figure in mind as it's important for what we'll discuss later on. By 1852, miners working deeper in Canadian Gully had uncovered further deep leads and many other leads that flowed into it. These leads were ancient riverbeds, buried under sediment for millions of years. Swift's early efforts to explore this area directly contributed to the eventual discovery of the deep lead system, including the rare and spectacular finds at Blacksmith's Hole. The incredible success of Blacksmith's Hole can be attributed to its strategic location, where 3 deep leads converged: Scotchman's Gully, Sailor's Gully, and the Prince Regent Lead. It's highly unlikely that the miners who sunk this shaft knew that this location was a strategic one, but it wouldn't be long until they realised that they had struck a level of success unlike any other. If you enjoy videos like this, be sure to subscribe and click the bell icon to be notified of every time we upload. These ancient rivers, now buried under sediment, met at a confluence before flowing into the Canadian Lead. Hydrodynamics played a significant role in concentrating the gold at this exact point. When multiple rivers converge, the water velocity decreases, creating ideal conditions for the heaviest particles, such as gold, to drop out of suspension and settle at the bottom of the river, in very specific locations that are dictated by a myriad of factors including the shape of the riverbed, the flow rate of the water, and any natural obstructions like rocks or bends. At this confluence of three leads, the interaction between different water flows caused a reduction in speed, allowing gold to settle more easily. As the water flowed into the Canadian lead, it straightened with a slight bend. This was a crucial factor in concentrating gold, as in straightened sections of rivers, gold tends to settle along the edges where the flow slows further. The location of the blacksmith's hole at the inner edge of a very small bend in the river, right at the confluence, placed the miners in a perfect position to access these concentrated gold deposits. The hydrodynamics combined with the natural geology of the region allowed for the accumulation of extraordinary amounts of gold. As a result, the claim yielded over 1 ton of gold, making it one of the richest small claims in Australian history. The area came to be known as a jeweller's shop because of the incredible concentration of gold found there. Miners struck gold in such quantities that claims were yielding 1,600 to 2,000 pounds per man, an extraordinary sum at the time. The Whitehorse Range's alluvial deposits, in particular, was proclaimed to be one of the richest areas ever opened, with miners reporting finding gold by the hundredweight, meaning in today's gold price they would earn $4.57 million. In some of the holes, gold was so abundant that it lay 3 inches thick in small hillocks, leading to sensational rumours of a table of solid gold being discovered. The difficulty, however, was as immense as the rewards. Miners had to dig holes as deep as 140 feet through waterlogged, unstable ground that required constant timbering and maintenance, a process costing upwards of £200 per shaft. Despite the success of Blacksmith's Hole, the miners faced challenges beyond the difficult work of mining. Reports indicate that other miners, eager to share in the wealth, intersected the claim from adjoining areas, stealing gold from the Blacksmith's Hole team. This was a common issue during the gold rush, as miners tunneled into neighbouring claims in search of rich deposits. But the theft did not stop the original team from extracting a tremendous amount of gold, but it added an element of tension to an already high-stakes operation. The wealth of the Canadian lead was not just due to hydrodynamic factors. The Whitehorse Ranges, located adjacent to the Canadian deep lead, played a crucial role in depositing gold into the ancient river systems that formed the deep leads. The quartz reefs in these ranges had been eroding for over 400 million years, slowly releasing gold particles into the surrounding waterways. These quartz reefs, rich in gold, were continually broken down by natural processes such as rainfall and erosion. The gold, carried by streams and rivers, eventually settled in deep leads, where it became buried under sediment. Over millions of years, the gold-bearing gravels accumulated in these ancient riverbeds, creating the rich deposits that miners like those at Blacksmith's Hole would later uncover. On geological maps, we can see the lines of gold-rich quartz reefs that were listed and crushed to extract their gold. There are numerous ones on the Whitehorse Ranges. Unlike other areas of Ballarat where miners had to break through tough basalt layers, which is volcanic rock, to access deep leads, the Canadian deep lead was covered primarily by sediment from erosion rather than volcanic activity, but I'll get back to this in a second. This made the gold more accessible to the miners working the Canadian leads, although they still had to dig through thick, unstable layers of clay, gravel and sand to reach the gold-bearing gravels below, and they had to contend with the never-ending flow of groundwater. The absence of basalt was an important factor in the success of the Canadian leads, as it allowed miners to access the rich gold deposits without having to contend with the hard volcanic rock that made mining in other areas more difficult, or that obscured its existence entirely. But as always, I've got to be honest, this area puzzles me. How were so many deep leads buried by sediment when they had been flowing for millions of years unimpeded? Did small-scale volcanic eruptions occur here, which eroded away by the time miners reached the area? Did some other form of tectonic process occur that is not yet clear to us? This remains a mystery that is unsolved, but I'm going to try to offer some speculation. On magnetics, there are small, tiny, dome-like structures that resemble highly eroded volcanoes right along the lead. I'll outline them for you. The modern-day Canadian Creek runs alongside these deep leads, but it's tiny compared to the aforementioned size of the deep lead rivers that used to flow here. So I'll let you make up your own mind regarding why these leads were buried, but I think volcanism and then sedimentation played a role in that order. I find it hard to believe that Whitehorse Ranges had just eroded so much that it buried a 30-metre wide river when it has been in existence for hundreds of millions of years, but I could be wrong. The Canadian lead is famous not only for the vast amounts of gold found in Blacksmith's Hole, but also for the discovery of some of the largest gold nuggets in Australian history. In January of 1853, 3 massive nuggets were found in the Canadian leads, including the legendary Canadian nugget. Shortly after, miners uncovered the Sarah Sands nugget, and another unnamed nugget. These discoveries made Canadian Gully one of the most celebrated goldfields in the world, and word of it had spread everywhere. The discovery of the Canadian deep lead, and deep leads more broadly, forever changed the history of Victoria and Australia. By opening up vast new sources of gold, deep lead mining fueled the Victorian gold rush, which brought thousands of people from around the world to the colony. The influx of immigrants and the wealth generated by gold mining transformed Victoria into one of the wealthiest regions on the planet. The city of Melbourne became known as Marvellous Melbourne during this period, as the wealth from gold funded the construction of grand buildings, roads and public infrastructure. Melbourne's population and economy boomed, and it became a global hub of commerce, finance and culture. The effects of the gold rush rippled across Australia, helping to fund infrastructure projects, establish new settlements and stimulate democratic reforms. The discovery of deep leads like the Canadian lead not only enriched the miners who found them, but also laid the foundation for Australia's growth as a nation. The story of Blacksmith's Hole is a rare and extraordinary story of luck and fortune. From Canadian Swift's early discoveries to the hydrodynamic forces that concentrated gold at the confluence of 3 deep leads, the success of Blacksmith's Hole is a remarkable example of how geology, luck and perseverance combined to create one of the richest small claims in history. Today we're going to discuss what is perhaps the most unique and incredible metal-rich deposit to have ever been discovered in the world. In the remote deserts of South Australia, where the heat scorches the earth and the land stretches into an endless horizon, lies a secret hidden beneath the red sands. A treasure forged by the most powerful forces of nature over billions of years. This is Olympic Dam, one of the world's most significant and unique mineral deposits, a geological marvel that holds immense quantities of copper, uranium, gold and silver. Olympic Dam isn't just a source of wealth for modern industries, it is an indication of Earth's dramatic ancient history, an untold story carved deep into the crust. And in this video we're going to do a deep dive into this fascinating mineral deposit. When we peer into the origins of Olympic Dam, we find an incredibly complex geological formation with few parallels on our planet. To understand how this deposit came to be, we must travel back through time, imagining the tectonic plates shifting, volcanic eruptions spewing molten rock, and hydrothermal fluids silently sculpting this remarkable site that's hidden beneath the surface. The Olympic Dam's story begins with the Gawler Craton, one of the oldest and most resilient pieces of the Earth's crust, holding memories of ancient geological processes that date back more than 2 billion years. The craton itself is like a relic of Earth's formative years, composed of igneous and metamorphic rocks that have weathered countless tectonic episodes. For millions of years, the Gawler Craton has been silently enduring, a steady foundation, fractured and reshaped by the incredible forces of geology that would eventually give birth to the Olympic Dam. Imagine the Earth in the Mesoproterozoic era, about 1.6 billion years ago, a planet in turmoil, with tectonic plates shifting and massive volcanic eruptions altering the landscape. During this period, the Gawler Craton was far from dormant. The ground beneath South Australia was a cauldron of molten rock, its surface rupturing in violent volcanic outbursts, with some eruptions reaching supervolcanic in their scale. These were the Gawler Range volcanics, part of the broader tectonic processes that tore the crust apart, stretching it thin and making way for the spectacular formation of Olympic Dam. The Gawler Range volcanics were more than just another volcanic event. They were a primal force shaping South Australia's landscape. Beneath the surface, mantle-derived magmas, molten rock from deep within the Earth, rushed to fill the cracks and weaknesses created by tectonic rifting. Above ground, lava flows and volcanic ash blanketed the land, but deep below, something much more remarkable was happening. As the magmas cooled beneath the surface, they solidified into massive plutonic bodies of granite, the foundation stones of what would become the Olympic Dam deposit. This immense magmatic event, known as the Hiltebah Suite, set into motion a slow, almost imperceptible process that would unfold over millennia. Magma cooled into granite, and during this process hydrothermal fluids, hot metal-rich waters, began to course through fractures and cracks in the crust. These fluids were the hidden artisans of the Olympic Dam, dissolving metals from the surrounding rocks and concentrating them in specific zones. The interaction between these magmas and the Earth's crust created a magical recipe for mineral wealth. Over time, the metals carried by these fluids, like copper, uranium, gold, and silver, were slowly deposited into the cracks and voids of the breccia complex, forming one of the most valuable mineral deposits in the world. Imagine deep beneath the Earth's surface, where the rocks have been shattered and fractured by tectonic forces. This broken rock, known as breccia, became the canvas for hydrothermal fluids to work their magic. The breccia is a chaotic mix of broken mineral fragments cemented together by finer materials, a geological collage created by ancient earthquakes and volcanic activity. It is in these fractured rocks where the most important work was done. The Olympic Dam breccia complex is vast, stretching across kilometers beneath the surface. As the Earth's tectonic forces pulled the Gawler Craton apart, the fractures in the breccia became passageways for hydrothermal fluids, which flowed through them like ancient rivers, carrying with them the dissolved riches of the Earth. Over time, as these fluids cooled and the pressure changed, the metals began to crystallize, clinging to the rocks and concentrating in the breccia complex. Here, beneath the parched desert, copper, uranium, gold, and silver were slowly locked into place, creating one of the most awe-inspiring deposits of wealth on the planet. But the Olympic Dam deposit wasn't just shaped by volcanic and magmatic activity. Above this brewing cauldron of metals lay a vast sedimentary basin, a quiet and often overlooked part of the story, but one that was crucial to the formation of this geological wonder. As volcanic rocks formed below, sedimentary rocks filled the basin above, trapping the hydrothermal fluids and concentrating their flow into the breccia complex. This cap of sedimentary rock acted as a lid on a simmering pot, keeping the metal-rich fluids contained and forcing them into the fractured rock below. The interaction between the sedimentary basin, the magmatic processes of the Hiltebah Suite, and the volcanic activity of the Gawler Range created the perfect environment for metals to accumulate. The basin added another layer of complexity to the Olympic Dam, contributing to the deposit's rich geochemical diversity. IOCG deposits, which are iron oxide copper-gold deposits, are a unique class of mineral deposits characterized by their abundant iron oxides, such as hematite or magnetite, and the presence of significant quantities of copper, gold, and occasionally other metals like silver and cobalt. They are typically formed by hydrothermal fluids that concentrate metals in brecciated zones or faulted structures, often in tectonically active regions. The Olympic Dam deposit in South Australia is one of the largest IOCG deposits globally, and what makes it especially unique is the unusually high concentration of uranium. While uranium is not typically a major component of most IOCG systems, in Olympic Dam it occurs in substantial amounts, making it the largest known single uranium deposit in the world. The presence of uranium alongside copper and gold is particularly remarkable because it suggests a complex interplay of geological processes, including hydrothermal fluid interactions with uranium-rich rocks, which is rarely seen on such a massive scale in IOCG-type systems, making Olympic Dam the world's largest known uranium deposit. These unseen rivers of fluid did more than carry metals, they altered the rock itself, transforming it into a rich geological tapestry, painted in hues of hematite and magnetite. The sheer scale of mineralization at Olympic Dam is nothing short of breathtaking. Imagine a deposit that contains 30 million tons of copper, 1 million tons of uranium, 1,100 tons of gold, and 6,800 tons of silver. These numbers are staggering, placing Olympic Dam among the largest and most valuable mineral deposits on our planet. But this mineral wealth is not evenly distributed. Instead, the metals are concentrated in different zones, telling a story of fluctuating temperatures, pressures, and fluid chemistries. In the central parts of the breccia complex, copper and uranium reign supreme, while gold and silver are more abundant in the outer zones, reflecting the changing conditions of their formation. The Olympic Dam tells a story of volcanic eruptions, tectonic rifts, and unseen rivers of metal-rich fluids that shape the world we live in today. It is a window into Earth's ancient past, a glimpse of the dynamic processes that continue to shape our planet. As we stand on the surface, gazing out over the remote deserts of South Australia, It is almost impossible to imagine the forces at work beneath our feet. But Olympic Dam reminds us that the Earth is alive, constantly evolving, and that its treasures, like the metals hidden in this deposit, are the result of billions of years of natural artistry. I hope you found this topic as interesting as I did, and as always, thanks for watching. The story of Lassiter's Reef is one of Australia's most captivating and enduring legends. It tells the tale of Harold Bell Lassiter, a prospector who claimed to have discovered a gold-rich quartz reef in the late 19th century, only to lose it in the vast deserts of Central Australia. Despite numerous expeditions and a century of treasure hunters searching for the legendary reef, it has never been definitively found, at least not officially. There is speculation that Lassiter's Reef may have already been discovered by others, but without anyone realising it was the same fabled deposit. To understand this possibility, we must explore the geological history of the Northern Territory and the orogenic events that created the gold deposits in the region. In 1897, Harold Lassiter claimed to have found an enormous gold reef somewhere in the outback, west of Alice Springs. According to Lassiter, the reef was rich with gold, embedded in quartz veins that stretched for miles. However, after losing his supplies and being stranded in the desert, Lassiter barely survived, leaving the location of the reef unmarked. For decades, Lassiter kept his secret, but in the late 1920s, he began to seek investors to help rediscover the gold deposit. In 1930, a well-funded expedition was launched. Lassiter's 1930 expedition to rediscover his fabled gold reef was one of the most ambitious and well-funded treasure hunts in Australian history, but it ended in failure and tragedy. This expedition, organised by the Central Australian Gold Exploration Company, also known as CAGE, set out to locate the vast gold deposit Lassiter claimed to have found decades earlier, and its story is one of miscommunication, distrust, and the harsh realities of the Australian outback. The company secured modern equipment, vehicles, and even an airplane to assist in the search. CAGE had high hopes that Lassiter's Reef would lead to untold riches and aimed to use the latest technology to find and exploit the gold. In July of 1930, the expedition set out from Alice Springs with great fanfare. Lassiter, claiming to know the way to the reef, was expected to guide the group westward toward the border of the Northern Territory and Western Australia. The team had high hopes and morale was initially strong as they travelled into the desert with a mixture of camels, vehicles, and air support. However, the expedition faced challenges almost immediately. The rough desert terrain proved too much for the motor vehicles, which frequently broke down. The conditions in the outback were harsher than anticipated, and the expedition's reliance on technology in a region where traditional bushcraft might have been more effective led to delays and frustrations. One of the critical problems that emerged early in the expedition was Lassiter's inability to provide clear and consistent directions to the gold reef. His memory of the region seemed unreliable, and a vast featureless desert made navigation exceedingly difficult. Lassiter gave the expedition contradictory instructions, claiming one moment that he recognised the landscape and the next that they had to travel further west. As the days stretched on, it became apparent to Blakely and other members of the team that Lassiter didn't have a clear idea of where the reef was located. Tensions grew between Blakely, the leader of the expedition, and Lassiter. Blakely, a seasoned bushman who was initially skeptical of Lassiter's story, began to lose patience, accusing Lassiter of misleading the group. Lassiter, in turn, grew increasingly defensive, maintaining that the reef existed and that they were getting close, even as the group wandered further into the desert with no sign of gold. After several weeks of fruitless searching, the expedition began to disintegrate. The motor vehicles were breaking down more frequently, supplies were running low, and the harsh desert conditions were taking their toll on the men and the animals. At this point, morale among the group was at an all-time low, and the leadership of the expedition was losing faith in Lassiter's ability to guide them to the reef. In September of 1930, Fred Blakely made the decision to abandon the search. Convinced that Lassiter had no idea where the reef was located, Blakely and most of the team turned back, returning to Alice Springs. However, Lassiter refused to give up. He decided to press on into the desert with a small party and a few camels. Lassiter was eventually left completely alone when his remaining companions abandoned the search. Now alone in one of the most remote and unforgiving parts of the Australian outback, Lassiter continued his search for the reef. According to his diary, which was later recovered, he claimed to have found the reef once again, but without the tools or resources to exploit it. He noted that the gold was as rich as he had remembered, but he lacked the means to take advantage of his discovery. Desperate and running out of supplies, Lassiter's health deteriorated rapidly, and he died alone in the desert, sometime in early 1931. After Lassiter failed to return, the expedition backpackers grew concerned, and a search party was sent out to find him. The search party, led by bushman Bob Buck, eventually located Lassiter's body in a remote part of the desert. His diary, found beside his body, contained some cryptic entries about rediscovering the reef and his final days in the desert. Lassiter was buried near where his body was found, but his diary only deepened the mystery of the reef. Although he wrote that he had rediscovered the gold, his vague descriptions and lack of coordinates left treasure hunters with little concrete information. The failure of the 1930 expedition and Lassiter's death did not end the legend of the reef. Instead, it further fueled speculation and fascination. Many have since speculated that Lassiter may have been confused, either by the harsh desert conditions or his memory, and that he never actually found the reef again. Others believe that the reef exists, but in a different location than Lassiter claimed. It's worth noting that Lassiter was not an experienced prospector or miner, and it's quite possible that he could have been confused by a quartz vein filled with chalcopyrite or pyrite or another similar looking mineral. His limited experience with mineral identification, combined with the stress of survival in a remote outback, may have led him to believe he had discovered a rich gold reef, when in reality it's possible he found a quartz vein filled with a sulfide mineral. This possibility adds another layer to the mystery of Lassiter's reef. If the reef was a misidentified pyrite deposit, it would explain why so many subsequent expeditions have failed to find the legendary gold. While most expeditions have focused on the western deserts of the Northern Territory, some modern researchers believe Lassiter's reef could lie further east, possibly in the more geologically favourable areas of central or eastern Northern Territory. These regions, shaped by significant orogenic events, are more likely to host the types of gold deposits Lassiter described. The geology of the Arunta orogenic belt and McDonald Ranges, in particular, suggests that these areas could be prime candidates for the elusive reef. The central Northern Territory has seen intense tectonic activity over hundreds of millions of years, creating the conditions for gold-bearing quartz veins to form. Some experts suggest that Lassiter may have intentionally or unintentionally misled others about the location of the reef, either to protect his discovery or due to confusion in a vast and featureless desert landscape. One intriguing possibility is that Lassiter's reef has already been discovered, but it wasn't recognised as the legendary deposit he described. There are several reasons why this could be the case. Lassiter's directions were famously vague, and the vast expanse of the Australian outback made it easy to misidentify landmarks. Over time, multiple gold deposits have been found in Central Australia, and it's possible that one of these deposits is the same as Lassiter's, but without the fanfare or realisation that matched his description. Central and Western Northern Territory are home to several well-known goldfields, such as the Tanami Desert and the Altunga Goldfield. These areas have produced significant amounts of gold over the years, often from quartz veins similar to those Lassiter described. It's conceivable that one of these deposits, particularly a smaller or less prominent one, might match the location of Lassiter's reef, but was simply not connected to his legend. The types of gold-bearing quartz veins Lassiter described are common in regions affected by major orogenies like the Strangest orogeny and the Alice Springs orogeny. If Lassiter's reef is located within these regions, it could have been mined in the early days of Australian gold prospecting without anyone realising its connection to Lassiter's story. Gold mineralisation occurs in regions affected by tectonic activity, where faults and fractures in the Earth's crust allow hydrothermal fluids to circulate. These fluids deposit gold in quartz veins, which are then exposed through erosion or mining activity. The most promising orogenies for gold deposition in the Northern Territory are the Strangest orogeny and the Alice Springs orogeny, both of which created favourable conditions for gold-bearing quartz veins. The Strangest orogeny occurred 1.74 billion years ago, and it is one of the most important orogenies for understanding gold mineralisation in the Northern Territory. It affected the Arunta orogenic belt, creating large-scale deformation and faulting that allowed for hydrothermal fluid circulation. This orogeny is responsible for the formation of quartz veins that host gold deposits. The Strangest orogeny primarily affected the Aileron province within the Arunta belt, which stretches across central Northern Territory. The faulting and hydrothermal activity created during the Strangest orogeny provided ideal conditions for gold deposits. These structures could easily match Lassiter's description of the gold-rich reef. If Lassiter's reef exists, it's likely associated with quartz veins formed during the Strangest orogeny, making the Arunta belt a promising location for the reef. The region's rich geological history makes it highly plausible that a gold reef like Lassiter's could be hidden in this area. The Alice Springs orogeny occurred between 450 to 300 million years ago. It had a significant impact on Central Australia, particularly the MacDonnell Ranges. During this orogeny, older faults were reactivated, creating new pathways for hydrothermal fluids and allowing gold-bearing veins to form or be further concentrated. If Lassiter's Reef lies within the MacDonnell Ranges, the Alice Springs orogeny could have exposed the gold-bearing quartz veins that Lassiter described. The reactivation of fault zones during this orogeny makes it a strong candidate for the location of the reef. Over the years, Central and Eastern Northern Territory has seen significant gold discoveries, many of which bear similarities to Lassiter's descriptions. The Tanami Desert goldfields, for example, are located in a region affected by the same tectonic processes that created gold-bearing structures across the Northern Territory. Likewise, the Altunga goldfield, located east of Alice Springs, has produced gold from quartz veins similar to those Lassiter described. It is possible that one of these deposits, or a smaller, lesser-known goldfield, matches the characteristics of Lassiter's Reef but was simply not recognised as such. Given the vague nature of Lassiter's direction and the challenges of navigating the outback, it's plausible that the reef was found and mined without anyone realising its connection to the legend. The legend of Lassiter's Reef continues to intrigue adventurers and geologists alike. While most searchers have focused on the western deserts, the geology of Central and Eastern Northern Territory, particularly regions affected by the Strangways orogeny and the Alice Springs orogeny, suggests that these areas are much more likely to host the gold deposit Lassiter described. Whether the reef has already been discovered and simply misidentified, or remains hidden beneath the surface of the Arunta orogenic belt or MacDonnell Ranges, the mystery endures. With the geological potential of these regions and the historical goldfields nearby, Lassiter's Reef may indeed exist, and perhaps, without knowing it, someone has already mined the legendary gold. So what do you think? Does Lassiter's Reef really exist, or is it just another fable in the rich history of Australian gold prospecting? Let me know in the comments. Thanks for watching.